Hi, today we're looking at Functional Skills Maths Level 1. This is the PearsonEdexcel exam board. We've got practice paper 1 and we're going to start from the non-calculator section. Question 1. Jack is keeping a record of the number of steps he takes each day. I'm going to put my commas in here to make it easier to read these numbers. And they're asking us to work out the range of the number of steps. Well, the range, that's going to be the difference between the biggest and the smallest value. So the biggest value is this one here, and the smallest one is this one here. And to find the difference, we're going to subtract the smaller one from the bigger one. So write the big one first, 15,323. And I'm going to line up this one below, so my thousands line up with my thousands, then my hundreds, then my units, and this is going to be a subtraction. So we'll start off with the units. 3 minus 5, we can't do that because 5 is bigger than 3. So reduce the 2 by 1, and we make this 13. So 13 minus 5, we've got 8. Now 1 minus 6, we can't do that, so we reduce to 3 by 1 to make that 2. And pass 1 over, so now we've got 11 minus 6, which is 5. Now 2 minus 5, again 5 is bigger than 2, so we're going to have to reduce that by 1 and make this 12 minus 5, which is 7. 4 minus 8 we can't do, so reduce the 1, that goes down to 0. Now we've got 14 minus 8, which is 6. So we've got 6,758, which we can write in here. Okay. Now, there's a part B to this question. Show a check of your answer. Well, a good way to do a check is to start with the answer and try and get back to what you started with. So if we're starting with this, we did a subtraction to get to here, so we do the opposite. So we're going to do an addition. So we're going to add on the 8,565, and it should take us back to where we began. So 8 plus 5 is 13, 5 plus 6 is 11, plus the 1 is 12, 7 plus 5 is 12, plus the 1, 13, 6 plus 8 is 14, plus the 1, 15. So 15,323, well, that is what we started with up here, so that's our check done. Question 2. Work out 1/4 of 24. Okay, well, 1/4, basically we're dividing by 4. So we want 24 divided by 4. Because of means times, so it's like 1/4 times 24. So multiply the 1 by the 24, divide by the 4, gives us 24 divided by 4. And if we use our 4 times table, 4, 8, 12, 16, 20, 24, that's 6. Part B. Work out minus 5 plus 3. Well, let's think of a number line. 0 here, minus 5 down here. We want to add on 3, so we're going 1, 2, 3. So we're going closer to 0, so it would be minus 4, minus 3, minus 2. And then part 3, or part C, right, 6.384, correct to 1 decimal place. Well, that's the 1 decimal place. So we look at the digit after it. If it's 5 or more, we need to increase this by 1. So we get an answer of 6.4. Question 3. Alan works at a warehouse in Runcorn. A furniture company needs deliveries from Runcorn to Liverpool. Actually, let's draw a little. Let's show this one here. Runcorn to Liverpool. And from Runcorn to Nantwich. Nantwich is down here. Alan needs to work out the total delivery charge for these deliveries. He uses this map. And we can see we've got a scale on here. 1 centimetre on the map is 10 kilometres on the ground. Then we've got some delivery charges. Alan uses these delivery charges. Distance from Runcorn and the charge. So if it's less than 20 kilometres, the charge is £9.99. If it's between 20 and 35 kilometres, it's £14.99. And if it's over 35 kilometres, the charge is £24.49. Work out the total delivery charge, show how you get your answer. So they want the total delivery charge, but we have got 2 separate deliveries. So first of all, we want to work out our distances. So we can measure this. I'll look at this on here. Liverpool to Runcorn, I get that at about 2.4 centimetres. And while I'm at it, let's measure Runcorn to Nantwich. I get that as 3.6, about there. I'm going to call that 3.8 centimetres. Now 1 centimetre on the map is 10 kilometres on the ground. So if we multiply this by 10, and by doing that we move the decimal point 1 place, that's going to become 24 kilometres because of this scale down here. Same on this one, if we multiply this by 10, move this over, and because of the scale that's going to become 38 kilometres. Now if we look at the charges, we've got 24 kilometres, so we're going to have one charge in here between 20 and 35, and the second one is going to be over 35 kilometres. So we've got £14.99 for one and £24.49 for the other. So we need to add these together. 9 plus 9 is 18. 9 plus 4 is 13, plus 1 is 14. 4 plus 4 is 8, plus 1 is 9. 1 plus 2 is 3. So you've got a total there of £39.48. Now with any questions like this, if you've got answers in pounds and pence, you want to have the pound sign, you don't want to put the pence in. The only time you put the p in is if you were only writing it in p. So we might have this as 3,948p. But once you've got the pound sign, don't put the pence in anymore. Okay, question 4. John works Monday to Friday. He buys his lunch on his way to work. Each day, John buys a sandwich, a bottle of water and a bag of crisps. We've got shop A and shop B. John thinks he will save more than £7.50 a week if he buys his lunch each day from shop B instead of shop A. Is John correct? You must show your working. Okay, so if he's going to buy it from shop A, well, let's work out what the total cost would be. So let's sort of think of this as like this in pounds. So we'd have 5 plus 0 plus 5 is 10. 8 plus 6 is 14. Plus 8 is 22. Plus another one is 23. Carry that over. 2 plus 2 is 4. So it costs £4.30 per day. Now for shop B, it's all part of the meal deal, so it just costs £3. So what we can do is work out what the difference is. So basically we've got £4.30 minus £3. So we'll put the zeros in. 0 minus 0 is 0. 3 minus 0 is 3. 4 minus 3 is 1. So he saves £1.30 each day. But he's working Monday to Friday. So Monday, Tuesday, Wednesday, Thursday, Friday. That's 5 days. So £1.30 times 5. Now if you notice I've ignored the decimal point for now. I'm going to put it back in afterwards. So 5 times 0 is 0. 5 times 3, 3, 6, 9, 12, 15. And 1 times 5 is 5, plus 1 is 6. Now, remember I said about the decimal point, it went in here, so we had 2 decimal places, so we go back in 2 decimal places there. So we've got £6.50 as the saving. Well, that's less than £7.50, so is John correct? No. He said he'll save more than £7.50. In fact, it's less than £7.50. And that's the end of the non-calculator section. Okay, so now we're looking at the calculator section. Okay, question 1. In June, Gemma paid £68 for her electricity. In July, she will pay 5% more for her electricity. Work out how much Gemma will pay for her electricity in July. Okay, so first thing we want to do is work out 5%, or 5 out of 100, of, which means times, 68. So this is going to give us just the extra 5%. We can use our calculator, so 5 divided by 100 times 68 gives us 3.4, or £3.40. Now we need to add back on the £68 because it's in addition to that, and it gives us 71.4, but because it's money we have to make that £71.40. Question 2. The table gives some information about the number of visits to a gym last month. So between 1 and 5 visits there were, and we've got a tally for it, we've got the frequencies missing at the moment, but they're asking us to complete the frequency column. So basically we need to add up the number of lines, but from a tally chart you should know that each complete grouping, 1, 2, 3, 4, is 5. So we've got 5, 10, that's our frequency. And we can do the same thing with the next one, we just need to count in 5s. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 41, 42, 43. 5, 10, 15, 20, 21, 22. And the last one, 5, 10, and one more is 11. Okay, so we've completed the frequency column. Now for part B, they want us to, on the grid, draw a suitable graph for this information. Okay, well if you remember we had number of visits were our groups, so we're going to have number of visits in here. And the different groups that we had, if we look back, these were our groups here. So we've got 1 to 5, 6 to 10, 11 to 15, and then we had more than 15. Now for the tally, well, we got the frequency, so we can just call it that. Frequency. Now the highest value we've got is 43, so we need to make sure this goes up to at least 43. Well, let's have a look here. 1, 2, 3, 4. So these are 5 each of these, so that would be 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, so that's going to work. So we can write all our values in here. And 0 down at the bottom. Now we've just got to draw our bars. So the first value we had was 10. So 10's here. I'm going to use a ruler for this one. There's my first bar. Now the next value we had was 43. So that's going to go, here's 40, 41, 42, 43. Okay, then for the next grouping we had 22. So here's 20, 21, 22 is going to be on there. And the last bar we've got is for 11. So here's 10, go up 1, 11 on here. There you go, all done. Question 3. Alfie sells flooring for playgrounds. He has this diagram of a playground. It's got a nice big rectangle with a lawn in the middle. And it says the playground is rectangular, 9 metres by 15 metres. The lawn is rectangular, 3 metres by 4 metres. Alfie will put flooring on all of the space inside the playground, but not on the lawn. So we want all of this area around here. The flooring costs £36 per square metre. Work out the total cost of the flooring. So we want the area. Well, area of a rectangle is length times the width. So we could work out the area of all of this, but we don't want the lawn. So we could then take away the area of the lawn in the middle. So if we do the big one first, we're going to have 15 times 9. And we can use our calculator. 15 times 9 gives us 135, and that's going to be metres squared. Now the lawn, the bit we don't want, that's going to be 3 times 4, which is 12 metres squared. So we want 135 minus 12, because we don't want the lawn bit. So this is going to tell us, 135 minus 12, it's 123 metres squared. And it costs £36 per square metre. So we want 123 times 36, we can put the pound sign in to show it's money, so the answer is going to have a pound sign. 123 times 36 gives us £4,428. A couple of pages to turn over. Question 4. Josh is designing gift boxes. He designs these boxes. So we've got 1, 2, 3, 4 boxes there. Josh needs to know the shape of the boxes from different views. So we've got some further shapes here. Place the correct numbers in the space to complete the sentences. So let's move this up. Okay, part A. Shape, and we need to pick 1, 2, 3 or 4, is the plan view of the cylinder. Well, the cylinder is this one, and the plan view is looking straight down on it, so we would see a circle. So it's going to be shape 1. Part B, shape, we need to fill it in, is the front view of the triangular prism. Well, this one is the triangular prism, so the front view is going to be looking that way. We're just going to see a big triangle, so it's going to be shape 4. And then questions, part C. The triangular based pyramid has number of faces, number of edges, and number of vertices. So triangular based pyramid, that's going to be this one here. So we want number of faces. Well, it's got 1 at the bottom, 2 there, 3 there, and then 4 this one on front. So we've got 4 faces. How many edges? Well, if you think of the base, we've got 1, 2, 3, and 4, 5, and 6. And vertices, well, those are the corners. So we've got 1, 2, 3, 4. It really helps with these if you can find some real shapes, real life 3D shapes, have a play with those. That helps you to get a good understanding of the difference between the faces, the edges, and the vertices. Question 5. Kate has this information about the total monthly sales for a shop in 2018. Okay, we've got a line graph there with total sales and the number of months. Kate needs to put this information in a table. The table must show the total sales for each quarter of the year. We've got quarter 1 is January to March, quarter 2 is April to June, quarter 3 is July to September, and quarter 4 is October to December. Draw and complete a suitable table for Kate. Okay, so what we're going to have, let's draw a table like this. So this is going to be our total sales, and we'll have quarter 1, quarter 2, quarter 3, and quarter 4. So for each of these, what we're going to need to do is to add up each of the values. So for quarter 1, we're going to want this. So we're going to want 160 plus 60 plus 150. We can use our calculator. So 160 plus 60 plus 150, we've got 370. And we can put that in here. Okay. Now we want to do the same for the next quarter. So this was April to June. So we've got 90. In fact, I'll write it there. 90, then 30, and then 10. So 90 plus 30 plus 10 is 130. Then for quarter 3, we've got July to September. So July is 40. August is 50, and September is 140. So 40 plus 50 plus 140 gives us 230. And finally quarter 4, October to December. So we've got October is 70, November is 90, and December is 140, so these three. So 70 plus 90 plus 140 gives us 300. And that's all we need. That's our little table there. Question 6. Karen is a cake designer. She is designing different shaped cakes. AB and BC are two sides of a parallelogram. On the grid, complete the parallelogram. So for these shapes, parallelogram means we've got two pairs of parallel sides. So we've got 1, 2, 3, 4 across there. So we need 1, 2, 3, 4 across here. So this is one set of parallel sides, and the other set is going to be going down like that. There we go. Okay. Here is a regular pentagon. Draw all the lines of symmetry on this pentagon. So line of symmetry is a line which goes straight through a shape so that you're splitting it equally in half and that you've got like a mirror image on one side and the other. So the first one, hopefully the easy one to spot, is straight through the middle. But actually if you think, well, if you turn the picture round, for example like this, hopefully you'll see, we've got another line of symmetry that goes straight through here. And we get the same again this way. And we've got another one coming down through here. And we've got one more through there. Now the trick with these is if it's a regular shape, then you should have the same number of lines of symmetry as you have sides. So we've got 1 line, 2 lines, 3, 4 and 5. This one we've already counted because it's just the other end of this line. Same with this one. Here is a regular hexagon. We've got an angle marked. What type of angle is angle X? Well, it's not a right angle. We know that a right angle is something like this, where you've got 90 degrees there. So it's not a right angle. Acute angle, well, that's anything smaller than a right angle. So something like that. So it's not an acute angle. A reflex angle, well, a reflex angle is a bit like this one, but reflex would be on the outside. It's more than 180. So it must be an obtuse angle. So that's an angle that's between 90 and 180 degrees. We've got another part to this question. Karen is making a birthday cake. The top of the cake needs to be triangular with one side length 10 centimetres, one side length 12 centimetres and a 90-degree angle between these sides. Draw the top of the cake for Karen. Use the grid below to draw the top of the cake. Okay, so you can see that each of these squares is 2 centimetres. So if we've got one side length of 10 centimetres, well, we can do 10 divided by 2 will tell us how many squares we're going to need. So 10 divided by 2, we're going to need 5 squares. And for the side length of 12 centimetres, we can do the same thing again. If we divide that by 2, we get 6 squares. Right, so let's draw the sides first. Well, we can start here. We've got 5 squares first. So 1, 2, 3, 4, 5 coming down. Then we've got a 90-degree angle between the two sides. So I'm going to make my 90-degree angle here. And then we're going to need 1, 2, 3, 4, 5, 6 squares this time. And because it's a triangle, we then just join up the corners. Okay, question 7. Daniel has these test results. Public services 46%, maths 14 out of 25, English 13 out of 20, art and design 6 out of 10. His tutor wants to compare these results. List the subjects in order from his best result to his worst result. Show why you think this. Well, we've got some percentages, some fractions. I'm going to turn them all into percentages. And the best way to do that is to treat this as a division and then multiply by 100. So in other words, for the maths, it becomes 14 divided by 25 times 100, and we get 56%. The English, we've got 13 divided by 20 times 100 is 65%. And art and design, 6 divided by 10 times 100. We got 60%. So now he wants to order them from his best result to his worst result. Well, what's the best? The best one is this 65. So it's going to be English first. Then the next biggest number is 60%. So that's going to be the art and design. Then the maths, 56%. And lastly, public services. Question 8. Write 3 over 60 as a fraction in its simplest form. So we want to look for numbers that go into both of them, or common factors. Well, the only factors of 3, the numbers that go into it without a remainder, are the numbers 1 and 3. Now dividing by 1 won't help because 1 goes into it 3 times. That's not going to simplify it. So we can divide it by 3. Well, 3 divided by 3 is just once. And 60 divided by 3 is 20. So that simplifies to 1 over 20. A group of dancers raised some money for a charity. Here is some information about the money raised. So 15 dancers raised £4.99 or less. 23 dancers raised between £5 and £9.99, and so on, with a total of 60 dancers. One of the dancers is chosen at random to give the money raised to the charity. What is the probability that this dancer raised less than £10? Well, one is picked at random. There's 60 of them, so it's going to be out of 60. And we're interested in the probability that the dancer raised less than £10. So that could be these ones, or it could also be these ones, because that's £4.99 or less, that's £5 to £9.99. So how many is that in total? Well, 15 plus 23, that's 38. So probability is going to be 38 out of 60. And you can leave it as a fraction. Question 9. Joanne is buying a pair of shoes in Europe. The length of her foot is 27.5 centimetres. Joanne uses these rules to work out her European shoe size. So we've got the length in centimetres, divide it by 2.5 and it gives us the length in inches. We then use the length of the foot in inches, multiply by 3, add 8, we get the European shoe size. Joanne thinks her European shoe size is 38. Is Joanne correct? Okay, well, let's do one bit at a time. So we've got 27.5. We're going to divide that by 2.5. And that gives us 11 inches. That's the first part. Now we take the length of the foot in inches. So we're going to take the 11 and we're going to multiply it by 3. Which gives us 33. Then we're going to add on 8, which will give us our European shoe size, which is 41. Well, 38 is not equal to 41. So is Joanne correct? No, she's not. Question 10. Sarah has a snack at work each day. She has this information about the snacks she had last week. So Monday she had a banana snack, which was 105 calories. Tuesday, chocolate, which was 260 calories. and so on. Sarah thinks the mean number of calories in these snacks is more than 200. Is she correct? Okay, well, for the mean, we need the total. We divide that by the frequency, or how many we've got. So the total, we're going to have to add these all up, but we can use our calculator. So 105 plus 260 plus 49 plus 257 plus 234 is 905, and we've got 1, 2, 3, 4, 5 days, which gives us 181 calories. Sarah thinks the mean number of calories is more than 200. Well, 181 is less than 200, so is she correct? No. Question 11. Ali is preparing for a race. He runs laps around a football pitch to prepare for the race. The length of each lap is the total distance along the four edges of the pitch. So we've got 90 metres here, 75 metres here. So this is going to be the same as up there. It's going to be another 90 metres. And this one is going to be the same as that. It'll be another 75 metres. Ali needs to run at least 10 kilometres. What is the minimum number of complete laps Ali should run? Okay, well, I know that we've got 1,000 metres in 1 kilometre. So if we want to know how many metres we need to run, we want 10 times 1,000. You can use your calculator, but hopefully you'll see that that is 10,000 metres. So how far is a lap? So one lap is going to be, well, it's going to be 90 plus 75 plus another 90 plus another 75 to get back to the start. So 90 plus 75 plus 90 plus 75 is 330 metres. So we want to know how many of these laps fit into 10,000 metres. So we can do 10,000 divided by 330. Which gives us 30.30303 laps. Now they said they want complete laps. If we just do 30 laps, that's not going to be enough. So we're going to need to do 31 laps. There is a second part to this question, and that's only worth 1 mark, but they all count. Show a check of your answer. So again, we can do a sort of a working back calculation. So what we can say is, well, we're going to run 31 laps. Each lap is 330 metres. So this will give us the total distance they're going to run, which is 10,230 metres, which is more than the minimum 10,000 metres they need to run. Check done. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on to find out when I upload more videos, and I look forward to seeing you again soon. Thank you.